My name is Evan Burness, and I work with the private sector program at NCSA. We are a different group than most of NCSA, whereas most of the folks who work here focus on open science missions, which is part of our mandate from the National Science Foundation. An extension of that mandate is for helping companies compete better through advanced modeling and simulation. When you make something by hand, which in our world we call experimentally, you're always limiting the amount of good data that you can collect about how high the quality is of the product you are trying to craft. When you do it with a computer, though, you can explore the design space in far, far greater ways than you can in the real world. And I'll give you an example. Let's say you are Rolls Royce and you make aircraft engines, and you wanted to test out 500 different variations of the same engine design. In the real world, you'd have to make 500 different engines. That'd be a very slow, expensive, tedious process. And you also would not be able to necessarily collect all the right data from that experimentation. In a computer, though, if you can create a true-to-life simulation of that engine and then make slight design modifications, you can take all of those, throw them at a big supercomputer, and look at all of the possibilities all at once. On iForge, we have about 2,500 CPU cores. We feature a number of NVIDIA GPUs in iForge as well. These are Fermi-class Tesla M2070 GPUs, about 17 terabytes of memory. It's supported by a 40 gigabit InfiniBand fabric from Mellanox and a 700 terabyte external parallel shared file system from Data Direct Networks. An additional system we use that Dell also participates is the Blue Water system. It is designed to be the first sustained petascale system on the planet. While the system is largely built with more than 750,000 AMD processor cores, the storage environment for the Blue Waters project features a 36 petabyte disk-based file system and a 380 petabyte tape-based file system. Something has to sit between those two systems, though, and move data back and forth. And that's where Dell comes in. Dell provides 78 Dell PowerEdge R720 servers and an additional 4 PowerEdge 815 servers as well. We test everything that comes into NCSA through a rigorous set of benchmarks. We found that performance per CPU, per socket, per dollar, per watt, all increased significantly from previous generation technologies. The C6145 has had support for multiple generations of AMD processors. And why that's really valuable is it allows a company to look at this product and say, this is something where if I invest in the reference platform, the C6145 itself, this platform can grow with me over time. I can add in new generations of processors, new capacities and speeds of memory, new kinds of interconnect technologies. It's a very flexible and adaptable platform to have. Every kind of problem that's going to come in the door to us is going to be really, really interesting. It's really going to push us, it's going to force us to think in new ways, and it's these kinds of problems that we then internalize and say, let's go build a computing system that specifically works on helping companies get through these kinds of challenges.